Hello everyone, welcome back to my channel Chemistry with ASR. So today we are going to look at the reaction mechanism of Sandmeyer's reaction. So in previous live stream we have learned about what is Sandmeyer's reaction, conditions, applications and many more. So today let us understand the mechanism step by step. Sandmeyer's reaction converts an aromatic amine like aniline into an aryl halide or nitrile using copper-1 salt. It begins with diazotization, then treating aniline with sodium nitrite and HCl at 0 to 5 degrees Celsius to form benzene diazonium chloride, followed by a radical nucleophilic substitution reaction. So now we are going to use CuCl, CuBr or CuCN to replace the diazonium group with a substituent called chlorine, bromine or Cl. Alright, now let us look into the preparation of diazotization or preparation or the diazotization of aniline. Diazotization of aniline. So this process starts by creating the reactive aryl diazonium salt. So what are the reagents that we are going to use? Aniline. It is a primary aniline and I'm going to treat it with CuCl at 0 to 5 degrees Celsius and I get a benzene diazonium salt N2 plus Cl minus. So this is called as benzene diazonium salt. Now this N2 is being replaced by the halogens like chlorine or bromine or any Cn group. Okay. Here the low temperature is maintained because this benzene diazonium salt will decompose. To avoid that decomposition of the diazonium salt, we have to maintain the temperature as low as 0 to 5 degrees Celsius. I hope this is clear. Next one, let us look into the mechanism of the Sandmeyer's reaction. Mechanism. So in the mechanism, step 1, so it follows single electron transfer method. So step 1 is single electron transfer. It's called as SET. Here the Cu1 sort like CuCl or CuBr. Okay, this acts as a reducing agent. It's an excellent reducing agent, and it's also an acts as a reagent. It's a catalyst as well. So what it does, it donates an electron to the arene diazonium ion. So it donates an electron to the arene diazonium ion, that is benzene diazonium ion. So you have N2 plus this is salt now. The ion means without the Cl. So Cu plus will give one electron to the benzene diazonium ion. So when Cl is not there, it's an ion. So you get the dot. So free radical is generated. So Cu2 plus is formed. From where? From Cu plus 1 to Cu plus 2. So this is the step 1. In step 2, loss of nitrogen. Loss of nitrogen. Loss of nitrogen. Here, the unstable radical intermediate. This is an highly unstable radical. Highly unstable radical. So therefore, it loses the nitrogen gas, forming an aryl radical. Okay. So let us see how it loses. N2 is this free radical is highly unstable. So therefore, it loses the nitrogen gas to form aryl free radical. The carbon bearing a electron, single electron. That's also highly unstable. So nitrogen gas is eliminated now. Next, in step 3, the final product formation. The aryl radical reacts with the copper 2 species to form the aryl halide and regenerate the Cu1 catalyst. So where did we find where did the Cu2 plus generate? It was generated in the step 1. This is step 1, this is step 2. Now the same Cu2 plus is going to take one electron from the aryl free radical and to form the product. So this is the step 3. Now here this is the aryl free radical that's going to react with the Cu2 plus that is generated in the step 1 of the mechanism. So CuCl2 or CuBr2. Okay, so this is Cu2 salt to give rise to chlorobenzene or bromobenzene. Along with that, the initially whatever the catalyst was used, that is regenerated. Alright, so what does it tell? So product is formed. I hope this is clear. The aryl radical reacts with the copper 2 species to form the aryl halide and regenerate the copper 1 catalyst that was used initially in the reaction. So therefore, we use to form the chlorobenzene. If at all I want to prepare the chlorobenzene, then what are the reagents that I'm going to use? I'm going to use CuCl along with HCl to give rise to chlorobenzene. Suppose I want bromobenzene, then I'm going to use CuBr in presence of HBr. Suppose I want benzonitrile, then I'm going to use CuCN along with KCN. Okay, so here why are we using KCN? That's the question. Do you know the answer for it? We are using KCN instead of HCN because it avoids the production of deadly HCN gas. This process is avoided when we use KCN instead of HCN. Now it also allows the formation of the soluble complex, which is very much necessary for the reaction to proceed efficiently. Alright, now there are another two reasons. One, the safety factor, the toxicity, to avoid the toxicity of the HCN gas. We are not going to use HCN here. One. Secondly, to maintain the pH of the entire reaction, maintaining the pH. So for that purpose, we are not going to use HCN gas. Instead, we are going to use KCN as one of the reagent. So you can just quickly go through what did we learn. Yeah, this was from the previous live stream. Conversion of diazonium salt into aryl halide. Applications. Then mechanism of the Sandmeyer's reaction. Step 1. Single electron transfer method, where unstable radical is generated. Later, loss of nitrogen gives aryl radical along with the removal of nitrogen gas. Later, this aryl radical reacts with the copper 2 salt to give rise to the desired product such as chlorobenzene, bromobenzene, or benzonitrile depending on the reagents that we used. So this is the very important reaction mechanism. I hope you all enjoyed. If you have any doubts, you can ask me now. Hello. Hi Charan. Hi Atman. Yes, very good, very good. All right, children. Then we will meet in the next live stream. Thank you.